All right, my friends, and we're back at it, and we are going to look at our final lesson of Unit 3. And actually, there's a couple typos here in the workbook. So this is Geometry Unit 3, Lesson 7 on page 135. All right, and it's actually standard 8.4. I can use my knowledge of angles to solve problems involving quadratic relationships. So little cut and paste job there that went awry. So, but that's where we're at, page 135, Unit 3, Lesson 7, using our relationships to solve quadratics. All right, so this is once again going to be very much like the prior two lessons, all right, except for the result is going to be a quadratic equation once we develop that or find the relationship of our angles. So just real quick, once again, just I want you to circle what you think are examples of our quadratic equations below. All right, pause the video, do that, and we'll see how you did. All right, so remember, quadratic equations have the highest power of x as a 2. So notice this is linear, so that's not quadratic. This would be quadratic. All right, this is a power of 3. That's what we call a cubic. You'll get to that in Algebra 2 next year. All right, x, y, and z. Ooh, that's definitely not a quadratic. All right, x squared. All right, so that would be a quadratic, and then another x squared right there. So those three are examples of our quadratic equations. All right, now, there are some specific things about quadratics that we have to remember, all right? Okay, so one, quadratic equations have some additional steps, okay? Now, here's what we know. All right, one of the differences is that quadratic equations usually have two solutions, all right? Two solutions, all right? Now, what that means for us is we have to be aware of a couple things. So, all right, in geometry, all right, here's one of the things we have to be aware of, right? Angles, all right, must be between 0 and 180 degrees. All right, so what that means is once we get our solutions, we have to go back and we have to plug it back in to make sure that that is true. All right, so if we get a negative angle, you know, we can't have negative degrees in an angle in this relationship here, and we can't have angles that are 190 degrees based on what we've talked about. So once we get our solutions, we have to go back and plug them in and make sure they work within the context of the problem. The other thing, all right, is I'm going to add right here is that our side lengths, all right, we're using angles here, so never mind, I won't do that because we're only working with angles. That's in the next unit down the road. Okay, so now, when we think about quadratics, all right, we must, all right, and this is one of the big ideas here, is that we must get our equation equal to 0. All right, we must get our equation equal to 0. So no matter what it looks like to begin with, so notice, all right, this is equal to 0. So notice we wouldn't have to do any prior work here, but both of these, all right, are not equal to 0. So we would have to move terms around to make it look like this, okay? All right, and then you have a couple of choices, right? So you might be able to factor to solve, right? You might be able to use the quadratic formula to solve. All right, and sometimes you might just be able to use square roots to solve, depending on, all right, what type of problem you end up with. So you have three different ways once you do get that quadratic equal to 0 of solving. Now, we're not grading you on which of those methods you choose, all right, and some are faster than others, all right, but you definitely need to know one, if not all of these, really, to be honest, all right, and feel comfortable with using any of those methods to solve. So, all right, let's go ahead and flip. All right, over to problem 1 here. All right, and let's look at problem 1 on page 136 here. All right, now once again, all right, what we want to do is look at the picture. We want to interpret that relationship in the picture into an equation. All right, so when I look at my picture here, I know it's going to be quadratic because I can already see that I have a power of 2 for an x here. All right, but now when I look, all right, there's some key pieces here that I know, and one of them is this. All right, and I'll give you guys a few seconds to pause the video and think about, like, what relationship do you see in this picture? All right, now, to me, the big piece is this. We have this marking here, which means, all right, we have complementary angles, right? So we know that the measure of angle 1 plus the measure of angle 2 has to equal to 90 degrees. All right, so now we have to take this information, right, and translate it into an equation. So what that means is 3x squared plus 20 plus 7x has to equal to 90. So that's the relationship, and then that's the equation we can create from our diagram here. Now, once again, notice, all right, I'm going to just do a little bit of rearranging here. I'm going to put my x term second, like that. And then here's what we know. It needs to be equal to 0. So now I'm going to subtract 90 from both sides. So 3x squared plus 7x minus 70 is equal to 0. All right. Excuse me, let me get a drink of water here. All right, so now looking at that work, now that it's equal to 0, all right, now we have to go through and either, right, factor, quadratic formula. We have to use some method, all right, in order to do that. All right, so now if we think about factoring, okay, if we think about factoring here, this is where we can do our area model. Now I'm going to do this just right over here on the side. All right, so we know the A term goes here, the C term goes here. All right, we always do A times C. So that would be negative 210. And we always add to get our B term here. So we always have to add to get our B term. Whoops, as I said B term there, but that is 7x. All right, so this is always A times C, and then this is always, all right, your B term, whatever that is. So what we have to do is we have to find the factors of 210, all right, negative 210 that add to be 7. All right, so I'm going to give you guys a second to pause the video, all right, and see what you can find. See if you can find, all right, two factors of negative 210 that add to be 7. All right, so coming back, there are no factors of negative 210 that add to be positive 7. All right, so that's the issue with factoring. So and here's what my suggestion would be is if you're going to factor, if you don't find this combination in a couple of minutes, don't keep going because it's very possible that that combination doesn't exist. All right. So then, right, if you want to factor, try it. And most of the time it's pretty quick. So if you can't find those combinations very fast, or you get to a very large A times C, all right, you might want to jump right into the quadratic formula. All right. So then if we think about the quadratic formula, there's A, B, and C. So we know x equals to the opposite of b plus or minus the square root of b squared minus 4a times c all over 2 times a. All right, so x equals to negative 7 plus or minus, and I'm just going to jump and put all this into my calculator. And this is what is nice about having the view screen is that you can type it in just like it looks. All right. Underneath that radical and get to your number. So then that's the square root of 889 divided by 6. All right. And so then x equals negative 7 plus or minus, and we can just do the square root of 889 here. And that's, notice, is not, all right, okay, an integer answer, which is why the factoring doesn't work. All right. So then if we look at our two answers here, so negative 7 plus 29.8 divided by 6. All right, and then x equals negative 7 minus 29.8 divided by 6. All right, and let's see what we get here. So negative 7 plus 29.8 and divide that by 6. All right, and so x is equal to 3.8. All right, and then if we do negative 7 minus 29.8, all right, and then divide that by 6, our second answer, all right, is negative 6.1. All right, so now what we have to think about, and this is where we have to go back and check our answers, right? We can only have positive angle measures, right? And it has to be between 0 and 180 degrees. So now when I think about 3.8, all right, I can see that it's going to be positive if I plug it in here because I'm going to square it. I'm also going to get a positive here. Now, once again, this is what works out well, right? We know that this was our initial relationship. So if I type that in, right, and this is once again where it's good to have the view screen because I can do my answer just like it looks into my equation like that. All right. Okay. Oh, I left the 7 off. So let me try that again. So 3 times 3.8 squared plus 20 plus 7 times 3.8. There we go. And notice I get 89.92. And notice we did a little bit of rounding, so that's pretty much 90. So that's telling me that 3.8, all right, is a good solution. All right, so that works out really well. All right. Now, if I go back and try negative 6.1, I'm going to do the same thing here. All right, and see if it works. All right, plus 20 plus 7. Keep trying to leave that 7 out. Negative 6.1. And I should get to 90. All right, and that looks like it's a little bit off, right? Now, looks pretty close. It's like, well, okay, that looks like it should work, right? It's almost 90, but then this is where if we go back and look at what the individual angles look like, right? So if I plug in here, right? If I look at the individual angles, notice 20 plus 7 times negative 6.1, that's a negative angle. All right, so you almost have to check both spots, right? And you kind of have to do a little bit of sleuthing here to make sure that it works in both situations. So if you only check the beginning, right, it looks like the overall relationship is like, oh, maybe that's rounding error. Maybe I'm good, right? But you also have to consider individual angles can't be negative. All right, so make sure you go back and look at both of those. All right, so get your two answers. All right, double check them, make sure it works, and you have a couple different places to check, right? Check your individual angles, make sure you get positive angles between 0 and 180, and check your initial relationship, all right, to confirm that. All right, so now, all right, you've got problems 2, all right, 3 and 4, and that is it, all right, for this lesson. All right, and then you'll be ready for your next self-assessment and then the test.